All right, so here we go on the key for 3.3. I think this was an example that we did, so we'll start right here, and we'll go through these relatively quickly because I think we actually did do some of these. But basically, all right, 1 and 15. So we're ignoring all this. 1 and 15 prove Q and R are parallel. Q is parallel to R, and the reason is because basically 1 and 15 are we can say, well, if alternate exterior angles are congruent, that's going to prove, or I'll just say then, parallel. Then the lines are parallel. All right, 3 and 7. Well, that 3 and 7 form sort of these. So we have T and S are the parallel lines. And I think we did these before in class. So, okay. But basically, 3 and 7 are corresponding. So if they're congruent, we can say, well, if those corresponding angles are congruent, well, then we can say then the lines are parallel. Okay. 6 and 8. Well, 6 and 8 actually they're releasing a transversal that goes through two different ones. Right? They do share sort of the two lines, but it doesn't really tell us anything about anything else. It's just relating 6 to 8. It doesn't relate any one of these angles to any one of these other sort of clusters. So we really can't tell anything about it. So in this case, we just sort of say not enough information. All right, but 52, this next one, right? We're saying the measure of angle 12. Right, so 12 here, and the measure of angle 15 here are 180. So they're supplementary. So in this case, these are same side interior angles, and they're supplementary, which is one of our theorems. So we do know that T will be parallel to S, and that's so if same side interior angles are supplementary, well, then our lines are parallel. All right. Let me get this eraser out here, go back there. And all right, so these next couple I don't think we might have gone through, so I'll go through a little more carefully. 8 and 14, what I'd say is, well, 8 and 14, 8 is made up of these two lines, and 14 is made up of these two. So 8 and 14 actually don't even share a transversal, so there's really not enough information for me to make any conclusion there. Okay, and then the next one is 8 and 10. So if we look at 8 and 10, 8 is made up of line Q, and line S makes up 8, and 10 is line R and line S. So we have S is our transversal, which means Q would be parallel to R. And again, it's parallel to R because 8 and 10 are alternate interior angles. It's like basically that would be 8 and that would be 10, so they're alternate interior angles. So we basically say if alternate interior angles are congruent, then the lines are parallel. All right, so then we get 13 and 11. So if we look at 13 and 11, 13's right here, sort of this. 11 is here, so we have, R and S here, right? So 13 and 11, we can hopefully see that those are alternate exterior angles, and so if they're congruent, the lines are parallel. So we're basically saying lines T and S. T is parallel to S, and we say, well, because if those alternate exterior angles are congruent, then the lines are parallel. And then 5 and 8, we have 5 and we have 8. Well, 5 and 8 are supplementary, and we know that. We could have done that sort of from a long time ago. So 5, and 8 are supplementary, but really they don't have any other angles as part of another sort of cluster. So really we have not enough information as well. All right, so then here is this proof, and I know for a fact sort of we walked through this in class. So it took us 9 steps. So we'll go ahead and say, I guess I can just go ahead and write this for the key purposes. So the first step is that angle 1 is congruent to angle 4, and angle 3 and angle 4 are supplementary. Again, I explained a lot of this already in class, so I might not explain or elaborate. I might, because I probably will not be able to not. All right, So that's given, right? That's that information. So what I'd say is, again, we're trying to end up proving that these are parallel. So if these, for L and M to be parallel, that's my goal. The only way that we can prove that they're parallel is one of those four properties that we talked about. And in this case, the only one that works is the fact that same side interior angles would be supplementary. So my goal is to try to get one into our supplementary, which means they would add up to 180. So I'm going to try to that's my goal. So I know that's where I'm headed. So now I'm going to start back up from the given and say, all right, we have 3 and 4 supplementary. Well, that means that the measure of angle 3 plus the measure of angle 4 is equal to 180. Now, at least I have an equation to sort of factor in and substitute in when I need to. But that's just the definition sort of supplementary angles there. Then we have 3. Well, now I'm going to go back up to the other given. It says, well, angle 1 is congruent to angle 4. So I'm going to say, well, that means that the measures of angle 1 are going to be equal to the measure of angle 4. And then again, that's just taking something that is congruent and saying the measures are equal. So that's just the definition of congruent angles. Then we have 4. Well, here's where I start to try to get to my goal, because I'm thinking, I know I want angles 1 and 2 to add up to 180, right? That means they're supplementary, and I can prove them parallel after that. So if I say, oh, look, if I'm actually looking at step 2, it says that their measure of angle 3 plus the measure of angle 4 equals 180. Well, I can actually replace the measure of angle 4 with the measure of angle 1 based on step 3. So if I said the measure of angle 3 plus the measure of angle 1 equals 180, I'm actually one step closer to having angles 1 and 2 add up to 180, because now I have 1 in there. So that's a good step. And all I did is basically substitute from step 3 into step 2. So that's substitution property of equality. And then if I'm looking down here, so now I have to sort of make this transition, because I'm thinking, okay, I want to get from angle 3 plus angle 1 equals 180 to angles 2 plus angle 1 equals 180. So angle 3 and angle 2, what do I know about them? So I go back up to this diagram. I go, oh, look, angle 2 and angle 3 are vertical angles. So I'm going to say, all right, well, we know because they're vertical angles, angle 2 is congruent to angle 3. And that's just because of our trusty vertical angle theorem, right, which says vertical angles are congruent. Okay. And then so now if I want to substitute that in, I can't substitute it into my equation like this. I have to sort of first say, okay, well, because they're congruent, that means their measures of angle 2 are going to be equal to the measure of angle 3. And if that is the case, it's the case because the definition, of congruent angles, right? And so now I can say I can take step 6 and substitute it in for step 4. And so we'll say the measure of angle 2, because I'm replacing 3 with 2, plus the measure of angle 1 equals 180. And that's it. That now I sort of know, okay, this is where I need to be. But why was I allowed to do that? Because all I did is substitute. So a substitution property of equality is good. And then so again, why was that was my plan, right? Well, then that's so that I can say that angles 1 and angle 2 are supplementary. And again, the fact that they added the 180 and now I can say they're supplementary, that's just the definition of supplementary. And then finally, now that I know that they're supplementary, I can make the conclusion that I'm looking for, that angle L is parallel to not angle L, line L is parallel to line M. And again, that's just because if same side interior angles are supplementary, then the lines have to be parallel. All right. Let's go to these. Use the theorems and information to show that R is parallel to S. So in this case, it would just be if 1 is congruent to 5. Well, that would basically be saying, okay, well, if alternate exterior angles are congruent, that means, so then we can say the lines are parallel. 3 and 4, so 3 is right here and 4 is right here. So we could say, well, 3 and 4 are supplementary, so it's kind of like the last step of that proof that we did. So if, same side interior angles are supplementary, then they have to be then the lines have to be parallel. And 3 and 7, well, those are alternate interior angles. So we could say, if alternate interior angles are congruent, which they told me they were, then the lines have to be parallel. And this last one, it's basically saying, well, 4 and 8, right? 4 and 8 are alternate interior angles. So that's basically the reason why, is that they're sort of the alternate interior angles. And what it's saying is that their measures have to be equal. So if I take in x equals 5 and plug it into both places, it shows that they actually are going to be equal to each other. So it's really just the same thing as kind of number 6 there. All right, we'll do sort of a small proof here. All right, so it says angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 1. And so that's our given. And then how are we supposed to say that 2 is congruent to 3? Well, angles 2 and 3 are congruent because of transitive, because 2 is congruent to 1, 1 is congruent to 3, and so therefore 2 is congruent to 3. So that's actually going to be a transitive property of congruence in this case. So that's nothing new. But this next part is we are trying to say that this, this line right here, xy, is going to be parallel to wv right here. And so the two angles that we have now are congruent are 2 and 3, which are all part of this transversal right here. So if I just break that down and say, well, what do I actually know? I know 2 and 3 are congruent. Well, oh, those are alternate interior angles. So now I do have enough information to say that these are parallel because alternate interior angles are congruent. So I can say, xy is parallel to wv because, and I'm just going to not have enough room, but I'm going to say if, alternate interior angles are congruent, then the lines have to be parallel. All right, here we go, another proof. We know that all the given information is up here. That's good. We know that 1 is congruent to 3 because because if we know these are parallel right here, BA and CD are parallel, well, 1 and 3 are corresponding angles. So again, we're sort of thinking, if other way around, sorry, it's actually, we know that they're parallel. So I'm actually not gonna have enough room. So that's fine. Where is it? There we go. So I'll just do it over here, and that would just be if the lines are parallel, because that's what we know in this case. If the lines are parallel, sort of then corresponding angles will be congruent. So that's the reason why I can say that. All right. And then we say that angle 1 is congruent to angle 2, 3 is congruent to 4. Well, that's actually part of this given. So we can just say given. Why is 2 congruent to 4? Well, if this is sort of a long chain here, but if 2 is congruent to 1, and 1's congruent to 3, and 3 is congruent to 4, so it's like 2 to 1, 1 to 3, and 3 to 4. Well, then we can sort of just say 2 is congruent to 4. And that's sort of like, that's almost 2 transitive steps in one, but that's transitive property of congruence. And then finally, we can say, well, because of all that, we know that 2 and 4 are congruent, right? It's marked on the diagram. And so, as we're trying to prove BC and DE parallel, like we're trying to prove these parallel, and we can because now we know corresponding angles are congruent, right? We're trying to prove these lines parallel, and we know that angles 2 and 4 are congruent. I marked them with 2, right? So we can actually say that. So we're saying, okay, yeah, BC is parallel to DE. And the reason why is because if corresponding angles are congruent, then the lines are parallel. And it's basically the sort of the converse of this one. Right? This one we said, oh, we knew that they were parallel, so the corresponding angles were congruent, was my conclusion. This one we're saying, if the corresponding angles are congruent, which I knew, then I can conclude that the lines are parallel. All right, so let's name the postulate or theorem that proves L is parallel to M. So if 8 is congruent to 6, well, that would basically be, well, if corresponding angles are congruent, then the lines have to be parallel. 2 and 6 are alternate interior angles. So we're basically saying if alternate interior angles are congruent, then the lines are parallel. 3 and 7 are alternate interior angles as well. So if alternate interior angles are congruent, then the lines are parallel. 8 and 4 are alternate exterior angles. So we have if alternate exterior angles are congruent, then those lines have to be parallel. 7 and 5 are corresponding. So if corresponding angles are congruent, then the lines are parallel. And 2 and 3 add up to 180, which means they're supplementary. So we know that if our same side interior angles are supplementary, then the lines are parallel. All right. Finally, the last ones here. It says, tell which pair of lines must be parallel, then name the postulate of the theorem. Very similar as the ones we did before. In this case, 2 and 10. So 2 and 10 are alternate interior angles, and 2, they share this transversal. So 2 and is on L, and M is on, and 10 is on M. So the lines that would be parallel would be M would have to be parallel to M. And the reason why is because if alternate interior, what in the world? Sure. If alternate interior, what? Weird things are happening, people. All right, we're almost done too. Come on, don't fail me now. All right, if alternate interior angles are congruent, then the lines are parallel. 1 and 7. Well, 1 is, and this is where it can get a little tricky, because we're basically saying, 1 is over here and 7 is over here, which means I'm not even going to look at any of this in here. I'm basically just looking at L and I'm looking at N. And if I ignore the middle one, the line M, it's basically, those are alternate exterior angles, right? And so we know that we can say L is parallel to N in this case. And that's because if alternate interior angles are congruent, then the lines are parallel. All right, so let's get rid of all this. And now we can say, all right, well, 11 and 5. Let's look at 11 and 5. 11 is right here. 5 is over here. So again, we're not really concerned with this whole middle line here. So we have this. We have this. We're not concerned with the middle. We have 11 is here and 5 is here. All those are alternate interior angles. And that would make L is parallel to N as well as the last one. So, but that's if alternate. Oh, sorry, the last one was exterior. I said exterior, and then I just wrote interior. So I'll just change that real quick. I knew they weren't the same. All right, so that is exterior, and this is interior. Angles are congruent. Then the lines are parallel. So congruent. All right, sounds good. And then 8 and 9. Well, let's get rid of all this. So if I'm looking at 8 and 9, let's use green. 8 and 9 are here. It's saying if they're supplementary. So then we know that M is parallel to N. Those are the lines that they're involved with. So if, same side interior angles are supplementary, then the lines are parallel. All right. So let's look at 33, which is 10 is equal to 6. So 10 and 6 are here and here. So we're sort of looking at these lines and ignoring this one. So we know that M is parallel to N because if, and those are alternate exterior angles in this case, are congruent, then the lines are parallel. And this brings me to a point here is that if you think about it, like some of these angles are interior based on, if you're, when you're comparing them to other angles, they're interior or exterior. For instance, angle 10, right? If I compared angle 10 to angle 2, well, then I'm looking at L and M as my two lines here, right? So they're on the interior. So they would be alternate interior. But if I'm looking at, that's not that, like the same angle 10, but when I'm looking at it in context with 6, well, now we're talking about these lines. So 10 is actually not on the interior, it's an exterior. And so these are alternate exterior. So it really depends on which angles you're looking at, which angles you're comparing, and then which two lines, what's the transversal, and then based on that transversal, what lines would be parallel. All right, so finally 2 and 5. So 2 and 5, we're ignoring this middle part. So 2 and 5 are supplementary, and so those are same side interior angles. So we'd say L would be parallel to N, and so if same side interior angles are congruent, then those lines have to be parallel. So all right, there we go. Thanks for watching.